Two horses pull a cart. Each exerts a force of 250 Newton at a speed of 2 meters per second for 10 minutes. Calculate the power delivered by the horses. How much work is done by the two horses? So first of all, I more or less picture what's the idea of the exercise. Okay, so I'm talking about horses. Okay, and I have two of them. So I'm going to copy and paste because this perfection you won't find it so often. Okay, there you go. You have the two horses. And these two horses are pulling a cart. Okay. And just okay. Now each horse is making a force of 250 Newton. And they're traveling at a speed of 2 meters per second. All this is happening in a period of time of 10 minutes. So this is like the schedule, the sketch of the problem, sorry, and what's given. All the information that I included there is given. For example, that force of of one horse is equal to 250 Newton. The speed of one horse is 2 meters per second. All this is happening at a time of 10 minutes. And here I notice one thing. You know, in what units we measure time? In what units do we measure the time?
In seconds?
So the first thing that I will do is to turn these minutes into seconds. Okay? So I will do the conversion directly here in the givens. So I say that in 1 minute I have 60 seconds. So in total I have 600 seconds. Okay? 600 seconds. Now in part A, they're asking me to find the power. And in part B, they're asking me to find the work that is done by each horse, okay? By the two horses, sorry. So by both horses, and the first one it says by the horses, so again by both. So let's take a look how we're going to solve this problem. First of all, we need to see what equation is better for us. In the first one, we need to get the power, okay? Take a look to what is given in this problem. It's given force, it's given velocity, and it's given time. So what equation do you think is the one that we need to use to solve this problem? 1, 2, or 3?
3.
This is 1, this is 2, and this is 3. In the number 3, I have force, okay, by each horse, and I have the speed. So yes, I can use the equation 3. So I say power is equal to force times velocity. Here I just plug in the givens and I say 250 Newton times the speed, that is 2 meters over second. So this is the power that is being done by one horse, okay? This is equal to 250 and 2, that makes 500. And look at the units, Newton, meter per second. This is what we know as watts. So this is the power done by one horse, 500 watts. But the problem tells me, calculate the power delivered by the horses. The horses. That means that I need to get the power of all the horses that are involved in the problem. I have 2 horses, so it's going to be 2 times 500 watts. In total, I have 1000 watts, or just 1000 W. This is all the power that is being done by the 2 horses. And with this, we finish part A. Do you have a doubt in part A? Okay, now let's work in part B. In part B, it says that I need to find the work done by both horses. Okay? Now, to find work, we can use the equation force times distance. Okay? We have the force, but do we have the distance? Is the distance given in the problem?
No.
It's not. So that means that if distance is not given, I cannot use this equation. Okay? But now take a look to what we're going to do. From the part before, we got the power that is done by the horses. So that means that now turns into new data. Okay? Now I know the power. So what I can do is, knowing the power, I can isolate for W. Take a look. In the first equation, I know the power already. I know the time already. I don't know the work. But I can isolate work to find it. So that is exactly what I'm going to do. I will use the first equation for power, and I will isolate for work. So power is equal to work divided by time. So this time is, you're not seeing, sorry. Power is equal to work divided by time. Time is dividing. So when you isolate it, you will send time to multiply to the other side. So you will have power times delta T equals work. And because of my OCD, I will write my work first, but the equation is the same. Power times the time is going to give me work. Now we just substitute by the givens. We have 1000 watts that are making the 2 horses, and the time that we already converted to seconds, that is 600 seconds. How much is this?
600,000
In what units do we measure work?
in joules.
In joules. So you can leave the answer like this, or you can write it in scientific notation like this. Both answers are correct. So remember, we're going to use the equations according to the givens. We use this equation because of these 2 givens that we had in the beginning. Okay? And then we find it work with this equation because the first equation we didn't have everything to get it. So we always need to see what is given and what we have. This one was not possible to be used, okay, because too many unknowns. In this one, yes, it was possible because we knew the power, we knew the time, so we just had to isolate for work, okay? So remember, we're going to use the equations according to the givens that are in the problem. Ready?
Miss, what if we can use two formulas of power?
What will be the other one?
No, it's just a. It's in this case, it cannot be right, but in any other problem, it can happen that two formulas can be used.
Usually the problem is going to give you the givens for a specific formula, but sometimes it's going to give you information for you to get the work, okay, like force and distance, and from work that you can get the power. That is something that can happen. That is going to happen in this problem, okay? Sometimes it's going to give you information to get work, and after you find the work, you can get the power. But two equations for power, I don't know, maybe, but so far one formula will be enough. Now, take a look at this example. It says, a 193 kilograms curtain needs to be raised 7.5 meters at a constant speed in as close to 5 seconds as possible. The power ratings for three motors are listed as 1 kilowatt, 3.5 kilowatts, and 5.5 kilowatts. Which motor is best for the job? This exercise is interesting. Take a look. The problem says that this curtain needs to be raised 7.5 meters. That means that here or here, the motor is going to be located. The purpose of the motor is that it can rolls the curtain, okay? So the curtain is able to get open. Now, you have three options of motors. 1 kilowatt, 3 kilowatts, and 5.5 kilowatts. 1 kilowatt, remember, the prefix kilo is 1000, so this is 1000 watts. This is 3500 watts, and this is 5500 watts. So we have listed three motors, and we need to choose the one that fits better this job. Now, this curtain, we know that it has a mass of 193 kilograms, and we know that it needs to be raised a total height of 7.5 meters. Okay? I don't know if you see very well the image. I think you don't. So I think now it looks better. Okay? So the mass of the curtain is 193 kilograms, and it needs to be lifted 7.5 meters. That is the height that it needs to be lifted. And all that has to be done in 5 seconds. Okay? We want the curtain to be up in 5 seconds because they don't want that it takes an eternity to go up. So they're not going to use a motor that is too weak that it takes an eternity to lift it. Okay, so they wanted that, they think that the time 5 seconds is a good timing to wait for the curtain to be up. So the first thing that we need to do is we need to write the data. Okay, we need to write the data. We know that we have a mass of 193 kilograms, and it says that it needs to be raised 7.5 meters. So the distance that it needs to be raised is 7.5 meters. Okay, in as close to 5 seconds as possible. Delta T is 5 seconds. And they're giving me the motors. Okay, so as you can see, the power of each motor, I mean, every power, every motor is measured in terms of power. That means that the label of each motor will depend on the power that it can provide. So we're going to have three options, okay? This is option 1, option 2, and option 3. So they're not giving us the work, they're not giving us force, they're not giving us velocity. They are just giving us mass and distance. Remember that when we were learning about work, we said that work for lifting objects or for objects that are going to be lifted, the work is going to be equal to force times distance. And the force of the object that is going to be lifted is the weight. So basically, this exercise is being transformed. Now the work can be calculated by using the weight. So we say work is equal to the weight times the distance. Weight, that is mass times gravity, multiplying the distance. And now we just substitute by the givens. How much is this?
14,200.
14,200 joules, rounded already, okay? So with this, we know how much work needs to be done. This is exactly what it means. This is the work that it takes to lift the curtain. Ese es el trabajo que la cortina necesita hacer, okay? That the motor needs to do to lift the curtain. So I want to buy a motor that is capable to do this job, okay? So in my second step, I will find the power. Take a look. I already have the work and I already have the time. So I can use the equation for power that is equal to work divided by time. So in this case, power is equal to 4,200 joules divided by 5 seconds. How much is this? How much is this?
It is 2,840.
Okay, 840. This is in watts. Okay? Remember that the prefix kilo means 1,000. Now, this is what I require. Okay, this is what I require. So now I need to choose the motor that fits better. Take a look. The first motor is only of 1,000 watts. Okay, so this motor is too weak. It won't help us to lift the curtain. So this one doesn't work for us. It's too weak. The second motor can do 3,500 watts of power. Okay, and it's bigger. Nosotros queremos un motor que sea capaz de levantar esa cortina. So at least the motor should be 2,840. Eso es lo mínimo que tiene que ser. If it's more than that, it's good. Okay? Entonces, the motor 2 is going to help us. The motor 3 also is going to help us. But the motor 3 is more expensive. También hace el trabajo, pero es más caro. So you, as the owner of the store, you probably want to choose the best option. The best option, the one that does the job and that is not too expensive. So the motor number 2